Welcome back. This time around, we are going to be looking at salt. Now, most times students will get scared when they are confronted with this topic called salt. Now, salt shouldn't give you issue. Just pay attention and actually I run through the series of salt. Alright? Now, what are salts? Remember, our neutralization reaction said that it is a reaction between an acid and a base to form salts and water only, right? So, salts are simply compounds that are formed when all or parts of the replaceable hydrogen ions of an acid have been replaced by metallic ions or ammonium radical. I will go all over that again. Salts are compounds formed when all or part of the replaceable hydrogen ions of an acid have been replaced by metallic ions or ammonium radicals. Now, if you have an acid, let's say HCl, you can still remember in our series of acids, I said that there's something that is called basicity of acids. That is the number of replaceable hydrogen ions present in one molecule of an acid. Look at this. This acid has how many hydrogens that can be replaced? One. So this is a monobasic acid. So pay attention to this now. If this is an acid and then the replaceable hydrogen ions happens to be one, which is this one. So if you are able to replacing this H with a metal or an ammonium radical, then it means it's certainly going to form a salt because by definition of a salt, they are compounds formed, or rather, salts rather, they are compounds formed when all or part of the replaceable hydrogen ions of an acid have been replaced by metallic ions or ammonium radical. So if I happen to replace this H here, it becomes metal, then Cl, then this is now classified to be a salt. Now, do you know that if I replace this with a known metal, let's say sodium, if I bring sodium and then I replace this H with sodium, then it ends up giving me NaCl. So this is a salt. Again, if I'm having another acid, H2SO4, now what is the replaceable hydrogens here? How many are there? Two. So it means if I replace this either completely or partially by metallic ions, then of course it forms salt. How many hydrogens in this case? Two. So if I bring one sodium here and I replace one H, it becomes NaHSO4. Yes, this is salt. Again, if I bring two sodium atoms and I replace the whole of the H here, and it becomes Na2SO4. Both of them, they are salts. Okay, so that's all about salts. You should know that salts are simply compounds formed when all or part of the replaceable hydrogen ions of an acid have been replaced by metallic ions or ammonium radicals. That's the definition. Then what are some of the features of salt? Do you know that salts usually occur as ionic substances? And what does that mean? It means that they are usually electrovalent in nature, in that you must have a metal and non-metal coexisting, or metals, non-metals coexisting. Alright? So looking at this kind of salt, you have a metal and then non-metals. You have metal, non-metals. You get the point? So they are usually ionic. And again, salt solutions usually have the ability to conduct electricity. Of course, going by ionic compounds, whenever they are dissolved in water, they have the tendency to act as good electrolytes, meaning they are able to conduct electricity. Alright? So now, let's see the types of salt without wasting much time. We have different types of salt. So the types of salt, there are about five. The first is normal salt. Normal salt, and we have the acid salt. We have acid salt. We have basic salt. We have basic salts, we have double salts, and we have complex salts. Complex salts. So these are the five types of salts that we have. So I'm going to explain them one after the other, especially in exam cases whereby they will ask you which of the following is an example of a normal salt, which of the following is an example of acid salt, and all that. So pay attention. Now looking at the first, normal salt. Now, normal salts are simply salts that are formed when all of the replaceable hydrogen ions of an acid have been completely replaced by metallic ions. Now, looking at this HCl, how many H do you have in this acid? One. So if I replace this H with, let's say, sodium, I've just replaced the whole of the H in that compound, this acid. And if I replace it, it becomes NaCl. So you can call this a normal salt. Yes, because all of the hydrogens have been completely replaced. Now let me give you another illustration. H2SO4. How many H do you have in this compound? Two. So if I happen to replace the two H with metallic ion, it forms Na2SO4. This also was a normal salt. So it means that when you have all the hydrogens to be completely replaced by metallic ions, then you can call it normal salt. And examples of normal salt includes NaCl, Na2SO4, K2CO3, Na2CO3, and the rest. Okay? Again, one unique thing about normal salts is that they are usually neutral to litmus. And what does that mean? It means they don't have any effect on litmus, meaning they are neither acidic nor basic. But there are still some exemptions to it, like looking at this normal salt, Na2CO3 and FeCl3. These two, they are normal salts, no doubt. But then again, this salt is having a basic, it has a basic property or action, it has a basic action on litmus, meaning that it tends to turn red litmus paper blue. Don't forget, this is the turn red litmus paper what? Blue. Why is that? Because if you dissociate this, or maybe when you dissociate in water, it ends up giving you Na plus CO 2 minus, and then water will be H plus and OH minus. So it's obvious that this attacks this to form NaOH, while this one attacks this to form H2CO3. So looking at these two, you are aware that this is a strong base, while this one is what? A weak acid. So strong base versus weak acid makes the solution to be basic, and of course it has basic action on litmus. All right, that's a normal salt that behaves abnormally. You get the point? The same thing is also applicable here, that when this splits, it ends up giving you Fe3 plus and Cl minus. So knowing the base and acid that led to the formation of this salt is very easy now. Coming from water, H plus and OH minus. If this one attacks the negative, it becomes FeOH3. Then while this one attacking this to form HCl. This is a strong acid, this is a weak base. So of course, this one will be having an acidic action on litmus, meaning it will change blue litmus paper red. So it's only seen in these two, okay, and some others too. But it's just that you should take cognizance of the fact that generally normal salts are neutral to litmus, the good majority, except these ones that behave abnormally. The next are the acid salts. Now, what are acid salts? Acid salts are simply salts that are formed by the partial replacement of the replaceable hydrogen ions found in one molecule of an acid by a metallic ion. Let me break it down again. Now, acid salts are formed when parts of the replaceable hydrogen ions of an acid have been replaced by metallic ions, meaning that it is not all of the replaceable hydrogen ions, but just parts. So follow. Do you know that if I'm having H2SO4, how many hydrogens can be replaced in this acid? Two. But then again, if I now happen to bring just one metal and then replace just one of the hydrogen, have I replaced it completely or partially? Of course, it's obvious it's partially. So it's only by partial replacement of the replaceable hydrogens of an acid by metallic ions that forms acid salt. So what I'm trying to say in effect is that if I'm just having one sodium atom replacing one of the H, it forms NaHSO4. In this case, I didn't replace the two H, I only replaced one with a metallic ion. That's partial replacement, and that ultimately gives what? An acid salt. So you have this to be an example of an acid salt. Other examples of acid salts includes, the first one I gave just now was NaHSO4. We have KHCO3, we have NaHCO3, etc. Now, it's very easy for you to identify your acid salts. How do you identify acid salts? All you simply do is just look out for H at the middle of the salt compound. That's the secret. So you look for H at the middle of the salt compound. If you are able to spot it, then you should know that that is an acid salt. And meanwhile, take cognizance of this. Acid salts are usually formed by the insufficient supply of base for the reaction. So meaning that when you are carrying out a neutralization reaction, what results in formation of acid salt is when the base is insufficient. Alright? So then again, of course, it's obvious that acid salts, in terms of their solutions, they'll be having what? Acidic action on litmus, meaning they change blue litmus paper red. Alright? Therefore, the basic salts, now basic salts are simply salts that are formed when there is insufficient supply of acid. See the twist. Acid salts are formed when there is insufficient supply of base, but basic salts are formed when there is insufficient supply of what? Acid. Okay? And it means that we are going to be left with hydroxide group seated at the middle of the salt compound. That's how you spot your basic salt. So classical examples of basic salts includes, we have magnesium hydroxide chloride, we have zinc hydroxide chloride, we have barium hydroxide chloride, etc. Now, how do you usually spot it? Remember I said for acid salts you have H at the middle, right? And then for basic salts you have what? OH at the middle. When I started, I told you guys that acids, they are characterized by their production of H plus in solutions, while that of bases, OH minus in their solutions. Alright, so that's that about that. Then the next is double salts. Now, what are double salts? Double salts are simply salts that are formed by the simple combination of two salts, and these two salts, they are usually simple salts. So it's just like the word double. When you have two things together, it forms double now. Alright, so when you have two simple salts coming together to combine, they form what is known as double salts. And double salts are usually characterized by two cations and one anion. Please don't forget this. This is the characteristic of double salts. Alright? So what did I say? I said double salts are characterized by two cations and one anion. What does that mean? It means when you dissolve double salt in water, it tends to dissociate into two cations and one anion. Don't forget, cations are considered to be the positively charged ions, while anion is considered to be the negatively charged ion. Alright? So now, you could have the combination of two simple salts, such as ammonium sulfate and iron 2 sulfate. Now you could have the combination of these two salts, and then it ends up giving you a double salt. And what type of double salt can you obtain from the combination of these two? When you add up these two, it can give you ammonium iron 2 tetraoxosulfate 6 hexahydrate. Okay, so this is an example of a double salt. And then another classical example of double salt that is common in your textbook that you can see in so many texts is the potash alum. That is the potassium aluminium tetraoxosulfate 6 dodecahydrate. That is this one. This is called potash alum. Potash alum. And of course, you know it has an application in water purification process that acts as a coagulant to tend to coagulate the fine debris in water into a big flow. Alright? So these are classical examples of double salts. And what are the cations here in this case? Of course, when you dissociate this one, you are going to be having NH4 plus, Fe2 plus, and SO4 2 minus. So these are the two positively charged ions called the two cations, while the one negatively charged ion being the anion. Alright, so these are classical examples of double salts. Okay, then for complex salts, complex salts are simply salts that are made up of a centrally located positively charged ion, which usually comes in form of a metal, and then it is linked to other electron donating species, which are considered as ligands. So it's just like you having a metal at the middle, and then it's linked to A, B, C, D, and E. Now, all these ones, they are electron donating species, and they are all considered to be called ligands. All right. So it's very easy for you to spot your complex salts. Like I said, there is a centrally located positively charged ion, which is a metal, linked to other species that are considered to be electron donating species, which are known as ligands. Okay, and then we have classical examples of complex salts. We have Na2ZnOH4, and then we also have K2 or K4 rather, FeCN6. Now these are the two main classical examples that you have in most texts, especially those of you that are writing your WAEC and your JAM, right? Now the name of this compound, this one, the first one, is called sodium tetrahydroxyzincate 2. Please don't forget the name of this one, this first complex salt here. While the second is called potassium then cyanoferrate then 2. All right. So these are their names. So these two are considered to be complex salts. All right. But please, never should you mistake complex salts for double salts. For that of the discrepancy in double salts and complex salts is that one, for that of double salt, I told you guys that when they dissociate in water, they dissociate into their respective ions. But in the case of complex salt, they do not dissociate completely. This one, double salt, they dissociate completely into their two cations and one anion. But in this case, this one does not dissociate completely. Let me give you an illustration so that you understand what I'm trying to say. Let's bring a double salt, potassium, KAlSO4. Don't forget the name of this one. I told you guys that this is called potassium aluminium tetrasulfate 6 dodecahydrate. This is a double salt. Now, when it dissociates, it forms K plus, Al3 plus, and SO4 2 minus. You see, two cations, one anion, complete dissociation. But in the case of this one, which is a complex salt, Na2ZnOH4. If I dissociate this, it doesn't dissociate completely. In that, when it dissociates, it forms something like this: Na plus and ZnOH4 then 2 minus. You see it now? So it was these two that came down to form this one. Hence, this is not complete dissociation. This is just partial dissociation. All right. So that's one discrepancy between double salt and complex salts. All right. And again, you should know that in terms of the double salts, they are characterized by two cations and one anion. Then in the case of complex, they are characterized by just a centrally located positively charged ion that is linked to other electron donating species, which are considered as ligands. All right. So please take cognizance of the examples of these different types of salts and also the points that I've just enlisted concerning them. So in our next video, we'll be looking at the properties of salt. We'll look at solubility rules of salt. All right. Thanks for watching and God bless. Don't forget to subscribe to this channel.